Hello everyone, welcome to our online open class. Today we are going to learn about the force operation of program design for cavity shape parts. It is about finish machining of the internal spherical surface. In cavity machining, the flat surface machining should be put in the first place and then the curved surface machining. We should also handle matters comprehensively in our lives. For this process, we have used the UG non-steep area contour milling method. The operation details of this method include selecting the central sphere and the adjoining fillets as boundaries. The cutting method used in the tool path includes a non-steep cutting mode that follows the periphery with the strategy set to up milling and inward. Reasonably choose the starting point of each layer with the cutting depth per tool pass defined as 0.1 mm. The programming steps are as follows. First, create an operation. We will use the non-steep area contour milling method. Specify the cutting area. Set the driving method. Set the tool path. Second, simulate the machining process. Please refer to the skill operation for details. Let's start the skill operation demonstration for the internal contour spherical surface fine machining procedure. First, select geometry, then right-click to access Insert. Find the procedure and choose non-steep area contour milling. Select a 6 mm diameter ball nose cutter. Choose the fine machining method and select Geometry B. Name the process Internal Contour Spherical Surface Fine Machining Procedure. And click OK. Select the cutting area by picking the spherical surface and its bottom surface. Then click OK. For the driving method, choose the area milling method, modifying parameters to steep and non-steep. Selecting following perimeter cutting method with the tool path inward, cutting direction conventional milling and the maximum distance set to constant with a step distance of 0.1 mm. Then choose the reciprocal depth machining method, setting the depth cutting layer to constant with a step distance of 0.1 mm and click OK. Modify the non-cutting parameters, setting the spindle speed to 3000 and the feed rate to 1500. Then click Calculate and click OK. Generate the tool path and click OK. Next, select the procedure. Right-click to find the tool path, then find OK. Adjust the animation speed to 4 and click Play. In ball end milling, the radius of the ball end cutter is typically smaller than the curvature radius of surface being machined. In CNC machines, the X and Y axis can move in tandem. while the Z-axis can move up and down independently, a method known as semi-tandem motion. When machining surfaces with minimum curvature variation and low precision requirements, semi-tandem milling is often utilized. In milling with non-steep area contours, to improve efficiency in non-steep area contour milling, a sequential approach is necessary. The optimal cutting mode is reciprocal depth machining. We speed up the animation playback, then click OK. Right-click to access post-processing and select the corresponding post-processing file. Set it to metric or imperial. Click OK and then OK again to overwrite the original file. The machining program is now generated. Modify and optimize the program as needed for your equipment. The skill operation is now complete. Today we completed the first operation of program design for cavity parts on the UG software platform. During the programming process, we used the non-steep area contour milling method. You can practice on your own following the operation demonstration. Correctly choose the central sphere and the drawing fillets as boundaries. The finished machining allowance is set to 0 by default. Now, if you are technicians, you should set parameters appropriately and optimize them in the program. Thank you for listening.